Hello, this is a new video, and here we are going to look at the Hekla region and the southern part, the Vatnafjoll fissure line. I think it's a fissure line. Here we have a view from south down till 30-kilometer depth. And what is obvious right away is that earthquakes stop around 12 to 15 kilometers. If I add the scale, now of course if we look from the side, we see this batch of earthquakes here, which belongs to the Vatnafjoll fissure line. It's nicely seen, it's a big pack of earthquakes. It is somewhat linear, going from west to slightly northeast. It's not very deep actually. As we say, it's around 12 kilometers where it ends. Now if we look at from the east, what we see right away are these two areas of earthquakes. Now these are all earthquakes since 2004 till the present time, so I think it's till 2 days ago. So we see this batch here, which is below Vatnafjoll, and we see this one, which belongs to Hekla. And what is obvious right away is that Hekla has this lateral stack. It goes towards the northeast with depth, so it's very interesting. It looks like it's avoiding something here, or it just could be where the fissure is actually going with depth. It's actually going to the north slightly. If we look at from below, you can see the earthquakes in the Hekla line are actually quite nicely oriented from southwest to northeast, so that's probably where the fissure is going. Now if we look only at quakes till 2004 and 2010, you see there are not a lot of quakes under Hekla actually. There are some around the fissure, but just a few under the main hill, the vent. But we do see here quakes at depth under Vatnafjoll, but not really any shallower. Now if we look at 2011 till 17, you can see how the activity actually picked up. Now since 2004 to 2010, there were not so many quakes, so we see that Hekla has really picked up, especially under the main crater and along the fissure line. It is interesting how it's actually going very towards the north with depth, north and northeast. And of course Vatnafjoll region. If you look at all the quakes again, these are all the quakes. We do see the Vatnafjoll region, big batch of earthquakes, but the shallower ones have actually appeared in the past few years. And the same goes for Hekla, which has picked this mid to lower range activity. We have here around 5 to 10, 12 kilometers in the recent years. And of course shallower under the main vent, the crater, or actually under the main cone, since Hekla is actually a fissure, I think. And what we have here are earthquakes of magnitude 1 and above. You see the same story. Hekla picking up, and this region of mid to a bit lower depth earthquakes at the southern part of the Vatnafjoll region. What is interesting, we see almost no quakes below 15 kilometers. If we look from the east again, we see that down to 15 kilometers is where everything kind of stops. Now I'm not sure how deep the Moho boundary is in this region. I think it's below 30, if I remember correctly, around 25 to 30. And we do have an M25, I think it was, quake here, down at around 27 kilometers, but it's actually a bit towards northeast of Hekla. It is kinda out of the ordinary to see it actually at that depth. But I guess since we have only a few years of data, earthquake data, it might not be so uncommon. Now what I have done is I artificially enhanced the size of the quake location, spheres, balls. It is just a visual thing. It doesn't have any connection with the actual area being, either cracked or affected by the earthquakes. It's just a visual thing to have a bit better feeling of the mass, of the area that the earthquakes are covering. Again, if we look from below, this is a bottom-up view. If you would go like the 30-kilometer depth and look upwards towards Hekla, you'd see this region of quakes under Vatnafjoll and this line of quakes in the Hekla fissure line. You can see 3 deeper quakes, but that's about it. All the rest up around 13 to 15 kilometers. You see the quakes here, which are actually at northwest, I think, yeah. Since this is turned around, northwest part of the Hekla cone, the stratovolcano, the cone, which is actually emerged recently. So there is strain being released there. Again, we see the line, nicely seen line of earthquakes. I'm not sure what else to say. I mean, it was based on a study done in 2011. It was said that based on satellite imaging, the SAR data and ground deformation, it was suggested that there is an area or a body, like a magma chamber below Hekla around 14 to 20 kilometer depth. Now that would agree with the seismic data, because we do see the earthquakes kinda stop around that region, around 12 to 15 kilometer depth. So that would kinda coincide. Now the deformation signals and data from the 2000 eruption actually showed a local coexistent deformation signal around the fissure. And it was said that it is actually consistent with a dike forming from the surface down to around 5.8 kilometers. And if we see or look here at the seismic data, we do actually see that the recent earthquakes do go down to around 4 kilometers in the actual fissure on the stratovolcano, or the main cone if you wish. So the data is kinda consistent. We have more earthquakes around a similar depth recently, or in the recent few years, where there have been dikes opening up in the fissure. Basically, it's the eruption site. But this one does look to be a bit more towards northwest, so there could be either a new dike forming in that area. It'll be interesting to see how the next eruption is going to look like. If we look from the bottom up, we can see earthquakes with depth going towards the north and northeast. So along the fissure line, very consistent data. If we look from the east again, looking from the east, we do see the same thing. Quakes in the vertical line going or tilting towards northeast under Hekla.